So let's jump straight into it. So real-time in Fme Server is one of the other core capabilities that we are going to be discussing. So the first core capability that we talked about was self-serve, and this next chapter is going to be reviewing real-time. So we define real-time systems as those that act on events as they happen and send information as it becomes available. So this can be implemented to monitor sensor networks or run event-driven processing. And we use real-time in Fme Server to send alerts out to external clients, such as a mobile device or email. So in Fme Server, real-time can arrive as individual events, or it can come into Fme Server as a continuous communication stream. So in Fme, when we're looking at tracking individual events, we use automations. Automations is a new functionality in Fme Server 2019. So if you have used Fme Server in the past, this was all done in notifications. However, since automations is new, this is what we will be reviewing in this course. But you may see online there's a number of articles and different help knowledge centers, etc., which refer to the notification service, which was used previously in 2018 and prior. So automations is how Fme Server handles individual messages coming in. And much like the Fme desktop canvas, automations allowed you to build visual workflows using trigger and action nodes that can be set up to listen to incoming messages into Fme, and Fme can then trigger a certain action in response, whether that is something internally to the Fme Server system or to send an external action such as sending an email or uploading a file, for example. And then the second real-time service that we have is message streaming. And message streaming, unlike automations, is designed to handle continuous flow of information rather than handling one-off messages. And this will be discussed in Chapter 5. So as I mentioned, automations have been built on the concept of the notification service, where a simple message comes into Fme Server to inform the system that a particular event has occurred. In automations, there are two different components: incoming triggers and outgoing actions. So incoming triggers are what Fme Server receives from a sending application, and then outgoing actions fall under two categories: internal and external. So we have internal actions, which allow Fme Server to submit jobs to Fme Server, so to run a workspace on the server based on this incoming trigger. And then we also have external actions that are used to send notifications back out to an external client. So because automations are designed much like the Fme desktop workflow, automations allow you to incorporate a variety of different triggers and actions into one single workflow. So you could use automations to chain a number of jobs together, or you could have multiple different triggers designed to trigger the same job, for example. So automations should be used when you're looking to string together a number of different notifications, both incoming and outgoing. So there are a number of different elements of automations. First, we have the clients, and these are the external users or systems that send or receive the message. And then within Fme Server itself, as I mentioned, we have triggers and we have internal and external actions. And then the different use cases for these triggers and actions we refer to as protocols. So these are the different methods by which Fme Server can receive or send notifications. So for example, a trigger could be an email, a directory watch, or it could even be something internally within Fme Server, such as a schedule. So a client is a user, or it can also be a system that will send a message into Fme Server or receive that message. So this could be a physical person, or it could also just be a component of a computer system. But what's important to be aware of is the majority of clients are not a part of Fme Server, and this is something external that Fme Server just interacts with. So then within the automations component of Fme Server, the first thing that we have, and any automation will always start with, is a trigger. And a trigger is an Fme Server component that receives that incoming notification from a client. So in order to set up a trigger in Fme Server, we have an automations workflow page in Fme Server. And we'll dive into this in more detail once we get into the exercises. But essentially what we have is similar to Fme Workbench. We have a drag and drop canvas. So we can simply drop this trigger into the automations canvas. And then once we select it, there are a number of parameters that we can modify depending on which trigger we select. And then the second component of Fme Server automations is the action. And so we have two separate actions. We have internal and external actions. And in an automation, this could consist of both internal and external, or just simply one or the other service in response to a trigger. So Fme Server in an action sends these outgoing notifications to a client. And this is the only exception as to when Fme Server could also be considered the client if you are using one of these internal actions. So again, much like in Fme Desktop, you can then drop in an action node into the canvas, and they have these input and output ports which can be connected together so that you can see the flow of the notifications that you are passing through in the automation. So this is just some examples of the automation protocols that are most popular in Fme Server, and we'll be covering these in more detail in some of the exercises as we continue through today's chapter. So firstly, some of the common protocols used are watch triggers. So there are several different triggers that we refer to as watch triggers. Directory and FTP watch might be the most common ones, but we also have services such as Amazon S3 and Dropbox watch. And these triggers are protocols that watch directories and monitor folders for incoming files and any changes to that file storage system. So that might be new files, but it might also be modified and deleted files. The incoming message then contains the affected file path value. So this means that in your action, for example, you could run a workspace and process this incoming file. or you could send out an external notification to inform, for example, an administrator that there's been a change to a file on your system. For outgoing actions, we also have mobile notifications. So this allows you to send messages to mobile devices. And we have a mobile action for both Apple and for Android devices. So much like delivering out emails, this allows you to deliver a message to one of these devices based on the incoming message and potentially the internal action that you have performed as well. Other automation protocols that we have include Amazon triggers and actions, and we also have WebSocket notifications. But I'm not going to go into those in too much detail today because I think it's important that we jump onto the exercises so you can familiarize yourself with the automations canvas. So in saying that, let's dive right into the first exercise. So for this exercise, we're not going to be creating any workspaces to run. We're simply going to be setting up a directory watch trigger. So we're going to be setting up an automation that watches a resources folder on Fme Server for incoming files. And then we're going to write this information out to a log file in Fme Server so we can see what these incoming messages look like. So the first thing that we need to do to start this exercise is we need to jump back into Fme Server. So hopefully you're all getting the hang of this now. So in order to find the Fme Server Interface, we simply need to open a new web browser, and then we can go to http://localhost, and this should take us to the login page. Now, for this login page, we're going to be logging in as the administrator. So that's simply using the account credentials admin and admin. And once you're on the Fme Server page, we can access the automations canvas by selecting the automations from the menu on the left-hand side. And when you select this option, there are two different options. We have a build and a manage page. So the build page is where you can access this canvas and create and edit existing automations. And then the manage workflow simply shows you a list of all the automations that we have created so far, and also gives us some options to manage these, such as starting and stopping the automations, etc. So once we've created our first automation, we can go and have a proper look at what that page displays as well. But for now, since this is our first automation that we will be creating, we can simply select automations and then select build. So at this point, you should be presented with a page similar to the one that I am showing, where you have a Get Started pop-up on the screen here. And this page simply takes you to some of the articles that we have created to help you get started with developing new automations. However, for today's session, we simply want to move over to the Build tab on the left-hand side here, and then we can select Create New. So when we jump into the automations canvas, this is what the canvas will look like here. So we'll just do a bit of show and tell before we jump into the first exercise. So by default, we have what we've called guided mode on in an automation. And that means that you'll automatically have a trigger added to the workflow, which you can start to configure. On the left hand at the bottom here, we have the plus icon. And if you select this, you can see the different options for nodes that we have available. So we have triggers and we have internal and external actions here as well. And then lastly, we have the menu and menu icon ribbon at the top here, which we'll start to explore in more detail as we move through some of the exercises today. So first, let's get started on this first exercise. So before we create a directory watch in Fme Server, the first thing that we need to do is we want to create the resources folder that we are going to be watching. So in order to do that, we'll just jump out of automations and we'll go under resources. And once you've navigated to resources in the Fme Server web interface, we're going to create a new folder in the data folder. So we can first select data, and then we can select the create folder button at the top of the resources page here. Once you've selected the create folder button, we're going to add a folder called building updates. So once you've created that folder, we're now ready to create the automation using a directory watch that watches that folder. So in this example, just for simplicity, we're creating a directory within Fme Server, but you can also use the directory watch to monitor folders through a UNC path or through a resource connection as well. So it doesn't have to be exactly a resource that's actually on Fme Server. So once you've created the building updates folder in resources, head back to automations, build. And then we'll select create new under the getting started build menu. So thanks to guided mode, we already have a trigger on our automations canvas. So we simply need to configure this to be a directory watch trigger. So in order to do that, we can simply click on the trigger node, and then a parameter window will open up on the right-hand side where we can then start to configure these parameters. So in order to define this as a directory watch trigger, the first thing that we need to do is in the trigger details, select the trigger event. So this lists all of the available trigger protocols that we currently have available on Fme Server in automations. So the one that we're looking to use in this exercise today is the directory modified trigger. So we can go ahead and select that from the drop-down list. And once you've done this, you'll notice a number of additional parameters appear in this window that require setting up in order for this automation to work successfully and modify this trigger, modify this directory, excuse me. So the first thing that we need to do is we need to actually specify the directory that we want to watch. And that's going to be the building updates folder that we just created in the previous step of this exercise. So in order to do that, we can select the ellipses button on the right-hand side of the directory watch, and this will pop open the resources folders. So from there we can navigate to data, and we can then select the building updates folder that we created. And this is the directory that we are going to watch. So as you can see, since we specified the data folder, Fme Server has recognized this and added it in that environmental variable shortcut. So when you select OK, this parameter should be populated with the value Fme shared resource data / building updates. There are then a number of additional parameters which are set up to contain default values. So at this point we could start the automation, however it's not exactly how we want to set it up yet, so we're going to make some changes. The first two parameters that we have here are watch for subdirectories and receive notifications for folders. And we're going to leave these set to the default value of no, because we're only interested in monitoring files, because later on in an additional exercise, we're going to be setting up a workspace to process these files. So we don't want that workspace to be triggered if there's a change to a folder. The next parameter that we have the option to configure is the events to watch for. So that's if we want to receive notifications for file creation, file modification, and file deletion. And since we're going to be running our workspace, we only want to run this workspace when there have been new files added to the folder. So we're going to deselect the modify and delete options. So we're just going to have this set to events to watch for is create. And the final parameter for this trigger and for all triggers is the poll interval. And this means that once I start the automation for any watch triggers, how often do I want Fme Server to go and have a look in that folder to check for these new files? So 5 minutes is a little bit long for this exercise. We don't want to be sitting around waiting for this automation. So we can drop this value down, and we're going to drop it down to 30 seconds. It's important not to put this value too low. Excuse me. It's important not to put this value too low because this is using processing power from Fme Server. So if you set up a lot of automations or with a very low poll interval, you might notice your server starting to slow down. So 30 seconds is a reasonable interval of time to check that for that directory watch. So once we've completed filling in these parameters, we can simply select apply. And at this point, you should notice that this icon has changed from simply a trigger to specify that it is using the directory watch protocol. So at this point, let's save the automation just to make sure that as we go along and we make any changes, we're keeping the workspace saved. So we can select menu, and then from the drop-down list, there should be an option to save as. And so we're going to change the name to incoming building footprints. You also have the option to add a tag. So this is just an additional identifier. So for example, we could add a tag training to all of the automations that we create today. So we can see that they all belong to the same category. So there's one more step in this automation before we see it running. So in an automation, all automations need to contain at least one trigger and one action in order for them to be able to be started. So in this example, in order to see what information the directory watch is receiving, we want to add a log. So since we have guided mode on, this means that we have a grayed out next action icon waiting to be filled. So if we simply select this icon, next action details should appear, where we can then specify the log message action. So in order to do this, we can select an action drop-down menu, and then we're going to select log. And the log is an internal action, so it appears under the actions menu, and then we have a divider for all of the external actions that are available on Fme Server. So we're going to be selecting log. And then there are a number of parameters that we also need to configure to set this value up. So the first thing that we want to configure is what message do we want to be recorded. And all of the incoming messages in Fme Server are initially recorded as JSON. So if we were to select this drop-down menu, under the general folder, we would see event as JSON. So that is the entire incoming message. And then we also see a number of additional components about the automation and the event itself. However, we also have a separate directory folder. And what this shows is the different events contained within the event as JSON flattened out. So if we only wanted to record, for example, the file path and not the full message, we could select this rather than passing through the entire event as JSON that needed to be processed. However, since we're simply logging the message, we do want to see the message in its entirety so we can understand how the directory watch is passing information into Fme Server. So for this example, we can select event as JSON. So again, in order to do that, we simply selected the drop-down arrow here. And then under the general folder, we selected event as JSON. And the second parameter that we need to configure is where we want this log file to be written out to. So in order to do this, we can select the Browse button, and this will take us to Resources. And since we're simply testing at this point, and we're going to be modifying this automation throughout the exercises, we don't need to write this log file out to a permanent location. So we're going to be recording the log file in the temporary folder in Resources. So that's the temp folder at the bottom of the page. And from there, our log file doesn't currently exist. So we need to specify a name for this log. So once we've entered the temp folder, we can select this file name, and then we're going to write incoming building footprints.log in order for this to be successfully written out to this location. And then the last parameter here is if target file exists, then there's some options on how to handle that. So whether you want to overwrite the file or you want to append to a file. So in this case, the target file doesn't exist, so we can just leave the message as existing and leave it to append to file. So we've just had a good question come in, and we will be covering this later on in a later exercise. However, we had a question as to whether you can select multiple different messages from this drop-down list. So in order to do that, you certainly can. As well as having all of the different options here, we also have a text editor. And this text editor lists all of the different options, so you can simply select those and also write additional text. And then you can add, for example, more, so you can build up your own message using sections of the JSON as well. However, for today and for this exercise, we simply want to record the entire event as JSON. So in your log file parameters, they should now look like this, and you should have the entire event as JSON in the message. The log file location should be in shared resources temp, and then you should name that file incoming building footprints.log, and then you can leave the final parameter as it was by default and leave it set to append to file. So once we've selected apply, as you can see, the log file has 2 output ports, and this is the same for all of the internal actions. And this is simply a port for success and a port for failure. So if the log file failed to write, we could have an external action that was informing somebody that there was a failure on our Fme server. You may notice that if you start to add lots of additional actions, this guided mode might not be as helpful to you anymore. So you can always turn guided mode off by selecting menu and hide guides. This is just helpful for when you're getting started with automations. So now in order to start and test this automation, first we need to save the automation again. So we can select menu and save as, and then select OK to make sure that this file has been updated with the log file saved in there as well. Now at this point, the automation isn't actually running, so it isn't currently checking the directory watch for files. Since we were still in the editing process, there was no need for this automation to be checking that directory watch. However, now that we've configured all of the parameters, we're ready to go ahead and check that this automation is behaving as we expected. So we can now enable the automation by simply selecting the Start Automation button in the top right-hand side here. And once that's selected, you'll notice that this button turns to red and there's an orange ribbon, excuse me, an orange ribbon at the top, which indicates that automation is running. And once an automation is running, this means that the direct Fme server is now checking that directory every 30 seconds for any file, any new files going into that folder. And what's important to note is once you start an automation, you cannot edit it while it is running. So if we were to go ahead and make any changes to this, we'd need to stop the automation and it would no longer be monitoring that directory watch. So now let's go ahead and test that automation. So what we're going to do in order to test this automation is we're going to upload a set of shape files. And there are 2 separate ways to upload these to resources. You can either do this directly in the file system, or you can do it by using the Fme Server Web Interface. So I'm going to do it in the Fme Server Web Interface if you do want to follow along with that. So now we want to navigate to the Resources folder. And then we want to go into the data folder. And then we want to upload files into the building updates folder, since this is the folder that we specified the directory watch trigger to watch. So we can go into building updates, and currently there's no files in there, so we want to upload this series of shape files. So in order to do that, we can select the upload button, upload files, and this will take us into the Windows file directory. So we want to upload data from the building footprints folder. So in order to do that, we can go into the Fme Data 2019 folder under the Quick Access bar. And then we want to go into the data folder. And then we want to go into the engineering folder. And lastly, we want to go into the building footprints folder. And here we have a series of shapefiles on different building footprints. So we're going to upload the first series of shapefiles to this resources folder. So that is the update 001 shape folder and all of its associated files as well. So you should be uploading 4 files to the resource system at this time. So once you've selected all 4 of those files, you can simply select Open. And you'll see there's an indicator at the top of Fme Server that all 4 files have successfully uploaded. And of course, you can also see that all of these are now listed in the Fme Server Interface as well. So once you've uploaded these files, Fme Server is checking every 30 seconds as to whether there have been new files in there. So we can then go ahead and check in the temp folder to see if the log file has been written yet. If it hasn't, it just means that Fme Server hasn't reached that polling interval yet. So let's go ahead and see if this 30 seconds period has passed. So we'll go into resources. And this time we're going to be going into the temp folder, as this is the folder that we decided to write out our log file to. And as you can see, there is now an incoming building footprints log that was updated today. So once we go ahead and have a look at that log, we can see there's a number of messages from logger. And this is because we uploaded 4 separate files, and the directory watch will send an incoming notification into the log for each individual file. So as you can see here, we have the file path recorded as the .shape file, and then we have exactly the same message recorded for the .shx file. So this log simply shows the incoming message from the directory watch, so we can see that our automation is successfully monitoring the folder that we specified. However, there is actually also a log in automations for the entire automations activity, so we can also go ahead and have a look in there and see what information is recorded. So in order to view the log for this specific automation, we can go into automations, and this time we're going to select the Manage menu. So it looks like rather than saving that, it looks like I saved a separate file rather than rewriting over the existing one. So that's something that I'm going to go away and have a look at after this course, because that definitely shouldn't be happening. So if you have two automations in here, then just go ahead and have a look at the one that has the green tick symbol under the started list. So we'll go and select that automation, and as you can see, it's still running. But if we were to select menu, we have the option to view log file within here, and this is the log file for this automation. So rather than just logging the information coming in from the directory watch, it's logging all activity that's happening on this automation. So if we were to go ahead and view this log file, you can see that it's creating various different actions to assemble the automation, and it started watching this folder. And then you can see when it sends the create events for each of the different file paths that we uploaded. You'll also notice that if we look in this automation, you'll see there's a number of jobs being submitted. And this is because currently both the log action and the filter action on Fme Server are simply running a job that performs a logging message on Fme Server. So you've now created your first automation. So we're going to jump back into the authoring course now and review some more of the content before we then develop this automation further in later exercises to start submitting a job as well that processes that incoming file. So one of the main reasons to design automations in Fme Server is because it provides you the ability to run workspaces based on these incoming notifications. So in a simple automation setup, this requires a minimum of 2 components. So this is where a trigger sends a message to an action. And there are 2 separate options here. You can have a trigger sending a message to an internal action. So the previous exercise that we just created is an example of this. And then, as I mentioned, these internal actions also have outgoing ports, so you can start to join on additional internal and external actions if you wish. And the second option is to design a trigger, design an automation that goes from a trigger straight to an external action. So for example, you can have that directory watch and then send out an email reporting that a new file has been added, and there's no jobs run and no Fme engines are even being used in this demonstration. However, in that scenario, this doesn't include any transformation or restructuring of the message contents. So if the message needs to be processed in any way, then that's where the idea of these internal actions and employing an Fme workspace can be used within Fme Server. So let's have a look at 2 separate scenarios using Fme Workspaces within automations. So firstly, a workspace responds to an incoming trigger message. So in order for any workspace to be run on Fme Server without you manually going and clicking on that Run Workspace button, there needs to be some trigger to get that workspace started. So we've already covered an example of some of the triggers that we can use in automations. And from there, we can go ahead and add a workspace action that responds to this trigger. So for example, In the previous exercise, we could take that file path and then we could write that file and write the incoming data to an existing database and store that incoming data in a larger database. But then we also have Workspaces triggering an outgoing message. And this means that if, for example, you as an administrator want to know every time an end user runs a workspace, that means that what you can do is you can have a workspace itself send a message to what we refer to as a topic. And that's defined when you publish your workspace up to Fme Server. When you select different services, if you select the Edit Properties button, there's additional topics that you can choose the workspace to be notified from every time it's run. And that means that when somebody does go ahead and click that Run Workspace button, a message will be sent into the topic, which can then be used as a trigger in an automation and go directly to an external action. However, you can also have the workspace itself as both an action responding to a trigger and a trigger itself. So you can create a much larger chain where the workspace acts as an action and a trigger within the automation. So as an example, a trigger sends a message containing emergency events and the coordinates of the client's position. And then a workspace will run in response to that emergency, processing the coordinates. And then this will then trigger an external action to send a notification to the correct emergency response unit based on those coordinates. So in automations, the run workspace is labeled as an action because it requires an incoming message, so it must be set up by being connected to a trigger. So as we mentioned, the log file that we just produced was actually running a workspace. So just like when we configured that log file, it's exactly the same when we select the Run Workspace action, and we then have the additional published parameters that we're able to specify based on what's been set up in that workspace, and we can specify those to the different elements of the incoming JSON recorded in the trigger. So in order to interpret that message content, it's possible to pass the message, as I mentioned, as the entire JSON into the workflow, or for the majority of protocols, since we know the JSON elements, for example, for the directory watch, we know that it's going to consist of the file path and the file event, so whether it was created, modified, or deleted. This means that in automations, we've been able to flatten that JSON for you. And so you can simply select the different elements of the JSON to pass through into the parameter, rather than having to interpret and flatten the entire JSON in the workspace itself. However, there are some protocols under certain scenarios where you may have to pass the entire event as JSON, in which case you need to understand how to interpret that message. So the topic protocol is a good example of this. The topic protocol has a post URL, which means that it can be set up to receive messages from a third-party application. However, in this instant, the JSON may contain multiple layers, it may contain XML, depending on how that external client sends the information into the topic. And so Fme Server won't necessarily be able to flatten this information for you. So in order to extract that information from the topic message, you'll need to pass it into the workspace for processing. So in order to do this within Fme Workbench, we have a number of different JSON transformers that we can use to extract the different elements out of this incoming message. So in this diagram, as an example, for the directory watch, the JSON content would look like this, where you have the file path, the file event, the source, the time, and the event ID. So then in the JSON flattener, I would specify that I want to flash in the entire JSON, and I'd then see these as individual attributes listed in my workbench, which I could then go ahead and process. So of course, what you do with this message then depends on how you want to transform or process this step. So the important thing is that the topic message contents is not standard to the majority of other triggers, so you would need to process this information in an Fme workbench in order to have access to it. However, I believe other than the topic, all the other protocols have been defined in Fme Server, so you wouldn't have to flatten this JSON in any other process. So we're going to be continuing on from exercise 4.2. However, just because we are running short on time and we want to make sure we cover as much material as possible, we're not going to create the workspace today. We're simply going to use the end workspace that's available in Fme Data 2019. So we're going to be jumping down and starting at section 4 of this exercise. So the first thing that we need to do here is we need to open up Fme Workbench. Let me just close this notes down, sorry. Okay, so let's open up Fme Workbench and we can open up this completed workbench that we're going to be using in this exercise. So once you open Fme Workbench, to find this existing workspace, we can simply select the yellow folder open icon on the main screen. And from there, we're going to go to Fme Data 2019 under the Quick Access tab. And this time we're going to go into the Workspaces folder. And then we're going to go into the Server Authoring folder. And then we're going to be using the Real-Time Exercise 2 Complete. So once you open that workspace, you should see it is a very simple workspace. It simply consists of an Esri shapefile reader, and this reader was configured to merge all feature types, and this means that it's simply displayed as all. So when we upload this in our automation using Directory Watch, this will ensure that it is able to process all incoming files rather than just the update 001 file that it was designed or created with. And then the second component of our workspace is a writer, and this is simply a writer to a spatial light database. And this database is already existing and consists of various building footprints in Vancouver. And so all we're simply doing is we're writing this additional shapefile out into the database. So if we were going to have a look at our data, this is what the building footprints file looks like. And we're simply adding additional polygon buildings into this database. So since we're opening up the completed workspace, this means that it's ready to publish to Fme Server so that we can add this into our automation. So in order to do this, we can select File and Publish to Fme Server. Select the Fme Server connection to the local host URL. I believe that this will likely be called training on your machines. And then continue over to the next panel. So you can save this workspace into the training repository. And I'm simply going to rename this exercise to exercise 4.2, just to keep the naming convention the same as how I've been using it so far in these exercises. And now we don't need to upload any data files with this workspace because we're going to be having this workspace run in response to the directory watch. So the directory watch is going to be providing those source files into the workspace. So we can simply select Next. And again, we're only interested in the job submitter service because this workspace is running as part of an automation. We're not looking at returning any information into the web browser, so we can leave this set to the job submitter service, and then we can select Publish. So now we can return back to the Fme Server page in your web browser. And the first thing that we need to do is we need to add that building footprints spatial light database into a resources location on Fme Server. This is because the data is going to be written out to this existing file, and we're simply appending data to the existing database rather than creating a new one. However, that dataset is currently only located in the local directory, which Fme Server doesn't have access to. So in order to do this, we can select Resources, and then we're going to upload this file to Data, and we're going to create a new folder here called Output. So in Resources, Data, select the Create Folder button and create a new folder here called Output. And then we're going to click on this folder to enter it, where we can then upload the spatial light database that we are using in this workspace. So in order to do that, we can select Upload, Files, and then we want to go back to Fme 2019, Data, Engineering, and this spatial light database is also in the Building Footprints folder, where the shapefiles we uploaded earlier were located. So we can select Building Footprints, and then we want to select the building_footprints.sl3 file. So as you should now see, once that's completed, this file will be sitting in the Resources, Data, Output folder. So now it's time to edit the existing automation because we want to take away the log and we want to change this to be running this workspace and adding these newly uploaded files onto this database. So we can select Automations, and then we'll select Manage, and we want to update the automation with the log file that's currently running. So if you do have a window that looks like this, just select the automation that is currently running. So that will be the automation that contains the directory watch and the log file and currently has an orange ribbon at the top saying that it's not able to be edited at this time because it is currently running. So in order to make changes to this automation, we first need to stop it. So we need to stop it from pulling that directory watch. So we can simply select the Stop Automation button, and this will return to how the canvas looked when we first built the automation. So now we want to change this workspace, this directory watch from running a log to running a workspace. So in order to do that, rather than adding an additional node to the canvas, we can simply select this log folder, log node, and we can modify this so that it is instead using the run workspace action instead of the log action. So to do this, select log, and then for the action, we can change this from log to run workspace. As you will now see, this red exclamation mark icon has appeared on the node because this means this action is yet to be configured. So the first thing that we need to do here is we can select the training repository, and then we can select the workspace, and we'll be selecting exercise 4.2. And then you'll notice that much like on the Run Workspace page of Fme Server, once you've selected this workspace, additional parameters will become available. So these are the published parameters that we created, that would have been created on this Fme workbench. So the first thing that we need to do is we need to specify the source shapefile. And this source shapefile is going to be coming from the file path from the directory watch folder. So in order to specify that file, we can select the drop-down arrow on the right-hand side here. And then we can select directory. And under this are the two different elements of the JSON that are associated with the directory watch. So that's the file action and the file path. So we can select the file path as the input for the source Esri shapefile. And so this means that when we add a shapefile to that directory, this file path will be passed into the workspace for processing. We can leave the feature types to read as blank, as this is an optional parameter. And then for the spatial light database, this is the destination folder. So we can locate to that output folder SL3 file that we just uploaded. So in order to do that, we can select the Browse button. And then we'll go into Data, Output, and we'll select Building Footprints.sl3. So for your destination file, this should be the Fme shared resource data, outputs, building_footprint SL3 file. And then you can select Apply to configure this Run Workspace node in your automation. So before we enable this automation, there is one more step that we need to add in. So at the moment when we upload those files As we mentioned, a shapefile has a number of associated files that must be uploaded with it in order for it to be processed in a workspace. However, in a directory watch, when we logged those files, we saw there was an incoming message for each of these files. Now, if we left the automation how it was at this point, this would mean that the workspace would be triggered to run for each of those files. However, all of the files that do not end in the extension .shp would cause the workspace to fail. So in order to prevent us from triggering workspaces that we know are going to fail in an automation, we can add in an additional action between the directory watch and the run workspace node that uses a filter. So in order to do that, we can select the plus icon in the bottom left-hand corner, and then we want to add an internal action, so an action that's being performed in Fme Server. So we can select this icon and then drag it onto the canvas to add this filter. So once we've added this action, we can modify the connection lines so that the directory watch is going into the action port. And then we only want the file that passes through the filter to cause the run workspace to run. So we can add a connection line between the action succeeded port and the input port of the run workspace action. So the last thing that we need to do is configure this filter so that it will look at the file path value and only pass through the value with the contain string value .shp. So again, to configure that action, just like with the run workspace action, we simply need to select this node and the action details pop-up menu will appear on the right-hand side of the screen. So we can change this from a run workspace action to a filter action. And much like the log action, this will give us some additional parameters that we need to specify for this filter to run. So for the value to filter parameter, we can select the file path, so that sits under the directory folder. And then this is simply performing a string search in an Fme workbench, so we can do contain string is .shp. So you want to filter the file path value, and you want the file path that passes through to be the one that is the shape file. So we can then select apply. And we can now save the automation and start testing. So I'm going to select menu, and this time I'm going to select save as, and I'm going to save the automation as incoming building footprints 4.2 so that we can see how this automation is progressing throughout these exercises. So once you've started this automation, we can go ahead and start it, and we can repeat the process of testing the log file to test the solution and check that only the shapefile is being triggered, and we can check that the database has been updated. So once again, now this automation has started, it's polling the building updates directory watch every 30 seconds. So we can go ahead and upload some additional data into there. And this time we'll see that it has run exercise 4.2. So we'll go ahead and go into resources, data, and this time we'll go into building updates. And we'll repeat the process of uploading files. However, we're only directory watching new files, so we need to make sure that we're not re-uploading update 001. So this time we'll select upload, files, And this time I'm going to select the update 002 series of files. So once I've selected all 4 of those files, we'll select open, and we can monitor the automations, or we could also monitor the job history page to confirm that this workspace has been triggered to run. So if I were to go into the jobs completed page now, we'll just refresh this page until we see this workspace has been triggered. And we would expect to see this in a short while, since our automation is set to check every 30 seconds. So as you can see, exercise 4.2 was run successfully. And what you can see here is, much like the log message action, the filter message is in fact running a workspace on Fme Server. So you can see that the first filter message passed. So this is the shapefile that was passed on to run exercise 4.2. And then the other 3 filter message statuses failed because the file paths did not pass through the filter. So we're not going to inspect the data because I know that we're tight on time, and so I think it would be good to jump on to the next exercise. But what's important to mention here is that at the moment this filter and log message are running workspaces. So if you are limited to engines on Fme Server, then you might prefer to have a look at zipping up your files, and we can also have a look at doing that as well. So if you were to zip up your shapefiles before you uploaded them to Fme Server, this would only create one file path and one incoming message, which could then trigger that workspace without the need for a filter message. So the next thing that I want to introduce to you in automations is the use of email. And email notifications are probably one of the most commonly used protocols in Fme Server. And we have an email protocol for both a trigger and an action component. So this means that Fme Server can receive incoming emails from external clients, or it can monitor an external email inbox. And email actions can also be sent out to an external account as well. So email is not just a single protocol. There are a number of different email transfer protocols that exist. And so Fme Server supports both SMTP and IMAP protocols. So the SMTP protocol is the ability to receive an email through an email server that is actually built into Fme Server, or indirectly to send an email through Fme's SMTP service into an external account. And then the IMAP protocol is an indirect process whereby Fme Server can connect to an external account and monitor that inbox. So SMTP triggers are the ones when Fme Server data is sent directly into Fme Server via that built-in email system. And we're going to be covering this in the next exercise, so I won't go into it into too much detail now. But essentially all that you need to do in this trigger, it's really simple to create, and you simply need to specify a username, and then you'll use either the host name or the IP address to configure the rest of that email in order to send it into Fme Server. So IMAP triggers have a few more parameters that require being set, And this is because you are choosing to monitor an existing email account that you have. So you need to specify additional parameters such as the host and port name, as well as security details as well, and how often you want to check that account for new emails. And lastly, we have the email action, and this is an SMT protocol with parameter settings that are very similar to those with the IMAP incoming account. So you need to specify an account that you're going to be sending emails from, as well as you also have parameters that allow you to set the body of the text in the email. And this means that you can use information incoming from those messages as well. So for example, if you had a failed job on Fme Server, you'd be able to specify the job ID, the job name, how the workspace was triggered, and you'd also be able to add, for example, the log file as an attachment. So as an administrator, this is a really easy way to keep track of your Fme server system as well. So let's jump straight into exercise 4.3, which is going to look at modifying our automation so that these shapefiles can come in from a directory watch. However, we might find that not all of our clients have access to the resources folder in Fme Server, so we also want to provide them with the ability to email updates into Fme Server, which will also get updated into this Spatial Light database. So let's dive straight back into Fme Server to complete this automation. So the first thing that we need to do here is we want these file attachments that come in from Fme Server to be stored permanently on Fme Server. So we need to create a resource for them to be uploaded to once we add in an email attachment. So in order to do that, we're going to return to resources one last time. And then we're going to go into data. And then we're going to go into building updates. And we're going to go into this folder because this is where all the other files are being stored as well. However, we want to create a separate folder for the emails to be stored in to ensure that we're not triggering the workspace to run from the directory watch as well. So we can create a folder in here and we're going to call it emails. And since in the directory watch, we left the setting for watch for subfolders to no, this means that we can store this information in the same location without it being triggered by the directory watch. So now that we have a folder to store this information, we can go ahead and modify our existing automation to add a second trigger into the workflow, so the workspace is being triggered by both a directory watch and an email. So in order to do that, we can select Automations, Manage, and then we're going to select Incoming Building Footprints 4.2. You might notice here there's a little status icon that indicates there has been some errors. This status tracks the overall automations log file. And since this automation triggered some filtered jobs that failed, this is why the status is indicating that there are some errors, because it's telling you that the workspace, the automation ran some translations that failed. So we can select that automation. And we can go ahead and select the Stop Automation button in order to edit this automation. So the first thing that we need to do here is we need to add a second trigger protocol onto the canvas. So to do that, we can select the plus icon on the bottom left corner, And this time we're going to select the green icon. If you hover over it, it should tell you that this is a trigger icon. So we can select this icon and drag it into the canvas. And once we select this icon, we can then configure the email parameters. So in this example, we're going to be configuring this to have an SMTP protocol. So under the trigger, we're going to select email received brackets SMTP. So this username can really be anything you like. It's just going to be used to form the entire email address. So for this example, we're going to use Fme shape processing. Oh, if I can type, which I cannot. And then we have the option to download the attachments to a location on Fme Server. If you weren't to specify this, it would simply mean the attachments were downloaded to the temporary file, so they'd be available short-term use, but they'd be cleaned up out of the system after 24 hours. So this is why we created the emails folder. So we can select browse, and then we can select data, building updates, and we need to make sure that we're selecting this emails folder, which is separate from the directory watch folder. So for the download attachments to, we're specifying Fme shared resources, building updates, emails. And this username will be used to put together the email address that we'll be sending a shapefile into. There's also some additional information about the IMAP protocol. This is something that you want to investigate further in your own time. So once we've selected apply, we can then attach this email to the Fme Workspace that we are looking to run. However, the automation is not quite ready yet, because while the directory watch stores the source information in an attribute called file path, if we were to go ahead and look under the email folder, it stores the file path under a name called email attachment. However, what we want to do is we want to ensure that the source path is used whether or not it's coming from an email or a directory watch. So in order to do that, we want to create a key or a parameter with a common name for both the email attachment and the file path value that we can specify in this source shapefile. So in order to do that, we're going to be doing something called creating a custom key. And so this is something that we need to set up in both of the triggers, and then we can use that as that key in the source file. So in order to do this, we can firstly jump back into the email trigger. And next to the parameters tab, there is an output keys tab. And if we were to scroll to the bottom of this list lists all of the available keys that will come in from the incoming message. And then there's an option to add custom keys here. So what we're going to do is we're going to select the plus icon. And then I'm going to give this key the name user.shapefile. And we're going to set this to the email attachment value. So once I've created this custom key, this simply means that the email attachment value will be passed through under a different name. And I'm going to add the same thing to the directory watch so that I can use this user shapefile value And then depending on where the file path comes from, my workbench will be able to run whether it's being triggered from the email or from the directory watch. So this time we can jump into the directory watch, and then we can repeat the process of adding a custom key. So in the directory watch next to parameters, output keys, we can select the plus icon, and we need to make sure that we're giving this exactly the same name as we did in email. So we can select user shapefile, and this time we're selecting the file path as the value. So once you've selected apply, we can go into the workbench, and this is the final stage of this exercise. And under the source Esri shapefile, we're going to change this from just specifying the directory watch file path, and we're going to reference our newly created custom key. And so whenever a trigger comes in, it will use the email attachment or the file path value. So once we've selected OK, we can then apply, and our automation is ready to run. So now if you've got to this stage, we can go ahead and test the automation. So in order to do that, we can select Start. And this time what we're going to do is, because we did not send the email through the filter, we need to zip up all of those files before we add them as an attachment to email. So in order to do that, we can open up File Explorer, and then we can go into the Fme Data 2019 folder, Data, Engineering, Building Footprints, and this time we're going to select the Update 003 series of files. And as I mentioned, what we're going to do is we're going to zip these up into a single file, and that's because we're not passing them through the filter. So we can right-click, and we can send to a compressed zip folder. So once we've done that, you should be able to open up your Gmail account, and we can compose a new message. To send these files into our Fme server. So in order to compose that email, we first need to type in the username, which is Fme Shape Processing. And then we should be able to use either the EC2 machine name, or we should also be able to use the public IP address. Okay, so in order to find the public IP address for these machines, you can simply go over to Google, and you can type in my public IP address and select the top link there. What is my public IP address? And then you should be able to take this value here and copy that value and add it to the second half of your email. So it should be Fme shape processing. And then your IP, your public IP address. So then for the subject, we can simply specify incoming building footprints. And the only thing of interest to that workspace is that final attachment. So we don't need to add any message body at this point. We can just attach the files, and we can attach that updates 003. So we've just had a good question. What if you're not using one of the training machines and your server isn't public? If you don't have a publicly resolvable domain or DNS, then you'll have to explore the option of using the IMAP protocol. So the email trigger protocol sends messages into Fme Server. So in order to compile that email address, you'll need to have a publicly resolvable IP address. So now we can send that email into Fme Server, and we should be able to see, just like the directory watch, that if we go into the job history, this job should be triggered. So I know that we did go through this exercise fairly quickly. It's just because I'm conscious of the time, and we do want to try and get some information out to you on chapter 5 as well. So I think at this point, we're going to end chapter 4, and we're going to move on to Laura is going to take over for chapter 5.
While we're switching, I see there's another question.
Yeah, let me have a look. So just wanted to jump in, and as you can see here in the jobs completed page, this has now been triggered a second time from the automations, and we could see that the status is also successful. So let me just jump over and have a look at this question while we're switching. Yeah, so absolutely with automations, one of the great things about this is that you can expand your workspace as much as, or your automation as much as necessary. So in this example, I added multiple different triggers. I added a directory watch, and I added a email trigger. However, if you want to have multiple different email triggers, monitoring, for example, different IMAP connections, then you could certainly do that as well. Yeah, definitely. And I know that we have gone through this quite quickly, but myself and Laura are always open to questions, so that if you do have the time to run through this in more detail after the course and you have any questions, then you can always reach out to us as well, just through one of the support platforms. So I think now I'm going to hand over to Laura. So we're just going to pause the screen quickly while we do that.
Hello. Okay, so we're going to move on to, let's just look at some of the concepts in chapter 5 here. This exercise is actually a fairly quick one. There's not a lot of configuration we need to do, but it's a good way to demonstrate how message streaming works. So in the last chapter, we looked at automations, which is a good way to deal with messages that come in at a rate of less than 1 per second. So if you're dealing with things like emails, or if you're monitoring a directory or anything like that. What we're looking at here for message streaming is for high volume messages. So if you're dealing with a continuous flow of information, or if you have hundreds of messages coming in every second, there's some different techniques that we'd use to handle those. So in automations, those are great for those lower volume messages. The problem with those is if you start to get into these higher volume messages and you're starting up workspaces and running them every single time a new message comes through, you'll eventually hit a bottleneck, because it does take some time for a workspace to start up, run, process the data, and finish. So with message streaming, we're looking at kind of how to configure a workspace to be able to handle a continuous flow of data without needing to start and stop with every single message. So we have an example of data streaming here. So this is one of our demos that's available on our Fme Server Playground. Would you mind sending out the link, Colleen? Yeah, thanks. So we're going to send out the link through the chat to that if you wanted to take a look. But it's just an example of dealing with high volumes of data. So in this case, we're dealing with 3 different streams of information. So there's a live stream of bus data in the city of San Francisco, as well as airplanes and ship data. So all of that information is coming into Fme Server, and we have a workspace that's processing each of those messages as they come through and then displaying it on a web page. So this one uses a protocol called Websockets that allows you to display data in real time in a web page. So message streaming, the structure of a message stream is very similar to the way automations work. So you've got your sending application on the outside that sends information to Fme Server. Fme Server is the piece that does the processing. And then you have your receiving applications on the other side that can receive data from Fme Server. The difference in how message streams work is that they're actually controlled through specialized transformers within Fme rather than through triggers and actions in an automation. So we have a set of different transformers that can handle this kind of data. So there's a few different types of streaming protocols that we can support connecting to out of the box. So we have things like Apache Kafka, Azure Storage Service Queues, JMS, Kinesis, Simple Notification Service, and a few others. Twitter is an interesting one, so you can actually stream tweets as they come through. And WebSockets is very cool if you're going to be displaying data in a web page. So for each of those, we have different receiver and sender transformers that can be used to either receive information from the stream or send data out to the stream. We also have some transformers called connectors, and these are transformers that can work as both senders and receivers, so you can configure those accordingly. So this is an example of message streaming architecture. When you set up a workspace to handle message streaming, most of that work is done inside the workspace itself. So on one side, you'd have a receiver transformer that's configured to connect to the data stream. It'll connect to it, and basically it'll keep its connection open for as long as there's data coming through into the data stream. When you have a receiver transformer inside a workspace like this, and you run the workspace, you'll see the workspace will start up, it'll connect to the data stream, and it'll keep that connection open forever. So this workspace will never actually stop running. So it'll always be on and always running and always receiving new messages. So when you run a workspace like this on Fme Server, it will take up one of your engines. So it's something to be aware of. But the reason it does this is so that it's always available to receive the new messages as soon as they come through. And that's how we are able to process thousands of messages in a second like this. On the other side, we also have sender transformers, which will work in a similar way. They'll connect to the message stream. The difference with these is that they'll only keep running for as long as there's new data coming in. So if you have, say, a database connection and you're writing out to a sender, it'll keep the connection open for as long as there's data to read in that database. In some cases, you might have a receiver and a sender transformer in the same workspace. And in that case, you'd actually see that this workspace would also run forever, as the receiver is always on and always potentially receiving new data to pass on to the sender. So we'll take a look at an example of this in exercise 5.1. I think for the sake of time, I'll mostly just demo this one just to show you the idea. If you are interested in more details, definitely ask us through the questions panel and we can help you out with that. So for this example, I've got 2 workspaces. I have one that's generating messages that are going to be sent to WebSockets through a data stream. So for this example, we're faking up some emergency call data. So what we'd like to do is create a workspace that'll receive information about 911 calls coming in and then process that data and send out notifications as required. So for the first thing I'm going to do is just open up the first workspace that's going to create these messages and send them out. So this will give us a stream of data that we can connect to. So I'll just open up Workbench and open that. So don't worry about following along. I'm just going to go through this fairly fast. So this is my generate message workspace. So you can see in here, it's just generating some random messages and giving them random severity levels. And at the very end, this is the key transformer here, is this WebSocket sender transformer. So this is making a connection to a WebSocket server on our local machine. Fme Server actually does come with a WebSocket server built in, so you can use that if you wanted to work with WebSockets yourself. Here I'm making a connection to a WebSocket stream. So we're calling that stream emergency events. So this will let us know what kind of data is coming through. And then down below, this is our data to transmit. So this will be the message that we're sending into the stream. So we're just sending in information about the event message that we randomly generated. So I'll start this workspace running. We're using a decelerator transformer in here to slow down the message interval. So we'll be able to keep this going and have it send data for a while. So I'll run that. So this will be sending a message every couple of seconds. And this is going into that WebSocket stream. So at this point, we could pretend that we are the emergency coordinator and we want to be able to connect to this stream of information. So all of the 911 calls are coming into this WebSocket stream, and we'd like to connect to this data and process this as it comes through so we can handle these events in real time. So we've got a second workspace here that we can use to connect to that stream that we're sending the information into. So I'm just going to open up another instance of Workbench here and open that second workspace. So this one's also in our workspace directory, process messages. So here we go, it's fairly straightforward. I think, again, the key point here is this WebSocket receiver transformer. And this is the piece that's going to open a connection to the WebSocket stream where our data is coming from. So we've got the same stream ID that we're using here, emergency events. So we're connecting to that stream and then we're pulling in the JSON data from the WebSocket stream. We're using our JSON flattener and a vertex creator to create point data from those messages. We're writing them out to a database as we go. And then we're also using an Fme server notifier on the other side. So in this case, we're testing to see where the emergency events are happening. So we're looking at transit stations and we've created a buffer there. So we want to see when we get a cluster of emergency calls all around a transit station, we'd like to know that right away. So we're testing for that. So when they overlap, we're going to send out a notification to our Fme server and we can have alerts triggered based on that. So we can send this in and use an automation to receive that topic information and send out emails or run additional workspaces to really analyze the data and make sure we're handling these emergency events properly. So I'm going to run this workspace. You can see here we've got our WebSocket receiver making its connection with the WebSocket server. So it's done a little handshake and it's transmitted its connection information, asking that to watch for messages on that emergency event stream. So this workspace will never stop running. So if I keep this here, it'll always just remain in this running state and it'll always be connected to the WebSocket stream waiting for new messages. And we'll see as soon as new messages come through, they'll start logging into our workspace here and they'll start writing out to our spatial light database and we'll start processing that data. You can see here we've got messages that are sending out. I think on this side we're just not seeing them come through because we didn't put any kind of logging. So Not much to look at right now. Okay, so I'll let that run for now. I'm just going to skip into some of our wrap-up slides, and we can come check on this in a little bit here. But that's basically the basic concepts of setting up a message stream. So this is a good way to deal with high volume data. So you can create a dedicated workspace to always monitor for new information. What's nice with this is you can run this on FME desktop, not a problem, just like we're doing here for testing. But then you're always using up your workspace, so you're always using up Workbench on your local machine, which isn't necessarily great. So a good idea with these is to publish them up to Fme Server, so you can use a dedicated engine for those, and that'll let you offload the processing that's being done. And there are tools in Fme Server where you can set it up to always automatically restart the workspace if it stops for whatever reason. And you can monitor the progress on those and always check on those, and you have access to see exactly what's going on at any time. Okay, so just getting into the course wrap-up now. So if you're looking for any additional information about any of our products, or if you're looking for additional resources, the Safe Software website is a great place to start with that. You can get access to free trials for both Fme Workbench and Fme Server. Another great place to go is Fme, our Safe support team here. So if you ever are running into any problems, you can definitely contact us. There's a few different ways to do that. So if you have questions, if you're looking for kind of a how-to guide on how to do something, definitely recommend looking at our Q&A forum on our Fme community. So you can post questions there and have discussions with other Fme users and see if anyone else is doing something similar to what you're trying to do, and they can definitely help you out with that. You can always suggest ideas. If there's something that you've seen that you think would be really useful that doesn't exist in our product yet, you can always post an idea there to let us know what you'd like. Live chat, that's available during our office hours here. So if you ever have just a quick question or you want to get pointed in the right direction for some resources, definitely let us know through that. We're happy to help you out. Or if you run into any bugs or defects or anything like that you'd like to report, you can always report those straight to our support team. Yeah, here's a link to our Fme community here. So definitely a good place to go search, look for some tutorials, how-to guides, and post any questions or ideas you might have about Fme itself. Lots of good things on there. We also have a YouTube channel, so if you're interested in seeing some videos about, we have recordings of all our webinars and videos about different aspects of our product. It's a good place to look as well, so you can see new tutorials and additional information there. Another thing as well, course feedback. You can fill in the feedback forms. There's a link to that in our training manual right here. I think we'll also be sending you out an email with a link to the form. Please do fill that out and let us know what you thought of the training. If there's anything we can do to improve, or if there's anything that you wanted to learn you didn't see, just let us know through that. If there's anything that you thought went really well, definitely let us know. We'll make sure to, we'll definitely be taking that into consideration for future courses, and as we always looking for ways to improve our training courses. Finally, course certificates. So anyone who is logged on for the duration of this training course, you will be emailed a certificate just showing your to prove your completion. So you'll get that certificate in your emails within a couple of days after the course. And that's everything. So thank you very much for attending our training course today. I hope it's been a valuable use of your time for the last few days.